Hello and welcome to a new video on IGCSE Physics Classified Paper 2. In this video, we shall be discussing the concept of power. We will begin with concept questions. To calculate the power produced by a force, the size of the force must be known. What else needs to be known to calculate the power? So, just as a brief reminder, in order to calculate power equals work over time. This is work. And work is equal to force times distance over time. So what do we need in order to calculate power? We need three things. We need the force, we need the distance, and we need the time. So the correct choice here would be choice A. Two workers are stacking cans onto a shelf in a shop. The worker lifts the same number of identical cans on the same shelf from the same level. Worker P takes 3 minutes to lift the cans. Worker Q takes 4 minutes to lift the cans. Which statement about the workers is correct? So we have two statements about power and two statements about work. Now, since they are doing the exact same work in a sense, because they're lifting the same number of cans onto the same height, so the effort involved, the work done, is pretty much the same. So we definitely know that we cannot compare the work between P and Q. They're not less than or more than each other in any way. It's the exact same amount of work. But who exerts greater power? We know that power equals work over time. So P takes less time. So P has more useful power. Therefore, the correct choice here would be choice B. Worker P develops more useful power because they do the same amount of work, but P takes less time to do it. So B is the correct answer. A student is testing 4 different electric motors. He measures the time it takes for a motor to lift either a heavy load or a light load through a height of 1 meter. He makes a similar measurement for the other 3 motors. The table shows his results. Which motor produces the most power? So, of course, to get the most power equals work over time. So to maximize P, you want to increase P as much as possible. So you need to increase W and you need to decrease time. Using simple mathematics, if I have a fraction, if I increase the numerator, then the value increases. And if I decrease the denominator, then the value increases as well. Because, for example, which of these is bigger, 5 over 3 or 5 over 2? 5 over 2 is bigger than 5 over 3. Why is that? Because 2 is less than 3. So in a sense, you're dividing by, you're splitting something and giving fewer number of people. So if you're giving fewer number of people, each person gets a bigger share of a pizza, for example. So anyway, if we decrease the denominator, then the value increases. So we're looking here for the most work done. So we want the heavy loads, not the light loads. And we're looking for the least time taken. So the correct choice would be choice A. A man climbs a ladder. Which two quantities can be used to calculate the useful power? So again, power equals work over time. And work is equal to force times distance over time. And we have to note that in work, the force and distance must be parallel to each other. So in A, they said the weight of the man and the time taken only. B, weight of the man and the vertical distance moved only. So first of all, we definitely need the time, right? To make things easier for ourselves, let's remove any choice that does not have time. So B and D are definitely wrong. So which is it? Is it the weight and the time or the work and the time? So the weight is like F. So do I only need F and T, or do I need the work done as a whole and T? No, excuse me. I need the whole work done. So I need the work done by the man and the timetable. So the correct choice here would be choice C. Which two physical quantities must be used to calculate the power developed by a student running up a flight of steps? So this is similar to the previous question. And again, work done and time taken would be okay. So choice D is correct. An object is lifted vertically by a motor. In which example is the power produced the greatest? So we want to maximize power, right? So to increase power, power equals work over time. To increase power, I need to increase work and decrease time. So let's compare each of these. Now, here, shorter distance, that means I decrease the work, and longer time. So I'm doing the exact opposite of what I want. Same distance and longer time. So again, this is wrong because we want shorter time, not longer time. Again, here, shorter distance, that's less work. So I don't want that. So the only one that is remotely acceptable is D, same distance in a shorter time. And the correct answer is D. Now we move on to questions that require some numerical calculations. 4 different children run up the same set of stairs. For which child is the useful power to climb the stairs the greatest? Right, so again, we said that power is equal to work over time. And this is equal to force times distance over time. And here the force is the weight, so that's mass times gravity times distance over time. And we don't have the distance here, but should that worry us? No, it shouldn't, because of proportionality, basically. So if they're all going to climb the same distance and they all have the same gravitational effect, only for the purpose of comparison, we can say that power is equal roughly mass over time. It's equal to something else multiplied by that, but this something else is constant for everybody. So that's why we say proportionality, or we say P is proportional to mass over time. So for the greatest power, we need to see for which of these kids is the mass over time the greatest. Now, let's do some quick calculations. You don't have to get exact values, but if you write them even as fractions, 40 over 15, 50 over 25, 60 over 25, 70 over 50. So again, we want to maximize this fraction. So we want a small denominator and a big numerator. So for the ones over 25, we can definitely say that this is excluded because 60 is bigger than 50. And for the ones over 15, we can definitely exclude the 40. So let's compare these two. The 70 over 15 has a greater numerator and a smaller denominator. So that's definitely the highest value. If this analysis is confusing, you can use your calculator and find the decimals for each choice and then compare. But anyway, D, without any calculations, D is probably, or actually definitely, the most useful power created because it has the highest force and the smallest amount of time. So D is the correct answer. 3 boxes each weigh 100 newtons. A man lifts all the boxes together from the ground. Again, remember the classical Cambridge technique of confusing you by writing quantities in terms of letters. So let's underline that and write 3 on top of it because you're probably going to miss that if you don't pay careful attention. So we have 3 boxes, each of weight 100 newtons. A man lifts all the boxes together from the ground onto a shelf that is 1.5 meters above the ground. The man takes 2 seconds to do this. How much useful power does the man produce to lift the box? Right. So again, we know that power is equal to force times distance over time. Let's substitute. So the force here is 3 times 100. So the 3 is very important. And the distance here is 1.5. And the time is 2. So we can calculate the useful power as 300 times 1.5 divided by 2. And that gives us 225 watts. So the correct choice is choice B, because this calculation is equal to 225 watts. The child runs up a set of stairs 4 times. Again, if you ever see numbers written as letters, might be nice to just underline and write the number on top. The time taken for each run is recorded. Which time is measured when the child's useful power is the greatest? So it's the same child with the same weight and running up the same stairs. So the F and the D are the same. So the work done is the same. So to get the greatest power, you just need the smallest amount of time. So the correct choice here would be choice A, 10 seconds. A girl hangs by her hands from a bar in the gymnasium. She pulls herself up until her chin is level with the bar. The mass of the girl is 48 kilograms. She pulls herself up through a distance of 0.25 meters. She does this in 2 seconds. What is the useful power she uses to pull herself up? So let's go back to our equation. Work done, power equals work over time, which is just force times distance over time. Now, the force here is the weight of the girl, which would be 48 multiplied by 10, m times g. This is m and this is g. You can use 9.8 for g or 10. It won't really matter because you'll get almost the same answer and it will be very clear which choice is correct. So the distance is 0.25 and the time is 2. And we can just use our calculators to find the power. So 48 times 10 times 0.25 divided by 2 gives us 60 watts. So the correct answer here would be 60. So C is the correct choice. A crane on a construction site lifts concrete beams. The useful work done by the crane is 4,000 kilojoules in a time of 160 seconds. What is the useful output power of the crane? Now, remember that K stands for kilo, and kilo means you have to multiply by 1,000. So power equals work over time, and this is equal to 4,000 kilojoules, which is basically times 1,000 joules over the time of 160 seconds. So let's use our calculators for that. 25,000 watts. And this is equal to 25 kilowatts. So the correct choice here would be choice C. The vertical displacement of a mass of 0.2 kilograms changes with time. The graph shows how this vertical displacement changes. At which rate does it gain gravitational potential energy as it moves upwards? So you should know that gravitational potential energy is equal to mgh, and the rate of gaining gravitational potential energy, which is actually power, is equal to mgh divided by time. And we can now replace all the quantities. But bear in mind that we need to find a point on the graph to derive some quantities from it. So maybe let's just take the peak. The x-axis stands for time, and the y-axis stands for distance or displacement or height, basically. And the time at this point is 0.12. How did I get 0.12? You draw a vertical line here, you'll find that it lands at the 6th box. So if you count 6 boxes, you're going to find that this is roughly 0.12. Slightly greater than 0.1, which is midway between 0 and 0.2. And the height here is 2.5 centimeters. So you have to convert that, remember, to meters. Now the mass is 0.2, gravity is 10, height is 2.5 times 10 power negative 2 because we convert it to meters, and the time is 0.12. Then we use our calculators, so 2 times 10 times 2.5 divided by 100 or times 10 power negative 2. And then you divide your answer by 0.12 and you get 0.4 watts. Almost 0.4 watts. So the correct answer here would be choice D. A crane takes 2 minutes to lift a load to the top of a building. The change in gravitational potential energy is 360 kilojoules. What is the useful power output of the crane? Power equals work over time and can also be written as energy over time because work done is measured in joules and it's equivalent to a change in energy. So the change in energy here is 360 kilojoules. So that's 360,000. And the time is 2 minutes. So that's 2 times 60. And we just do the simple calculation. On the calculator, you get 3,000 watts. So that's equal to 3 kilowatts. A boy produces an average power output of 60 watts as he rides his bicycle for 2 minutes. How much useful energy does he expend? So power equals work over time or energy over time. And we are given that the power here is 60 and energy is the requirement, let's call it X. And the time is 2 minutes, so 2 times 60 to convert it to seconds. So we have a mathematical equation that says 60 equals X over 2 times 60, which is 120. So how do I get X? X is 60 times 120. And that's 7,200 joules. So the correct answer is choice D, 7,200 joules. And this brings us to the end of our video. I hope this was useful. Thank you for joining.